So welcome to iSet Robotics MOOC M2. This is already unit number 3. And the focus of this unit is the gears, the building and programming of the gears, and then the powered attachments. And I am Dr. Patricia Host, and I'm your presenter for this unit. So the unit 3 objectives include the gear models, so building gear models, and then considering the programming required to control the gears. And the second part is that we're building powered attachments using gears, and then to the programming that is required for these attachments. All right, so unit 3A, what are the gears? What is a gear? A gear is a machine part that rotates. It has usually got teeth and mesh with the teeth of another gear, and then they transmit the torque. And so why do we bother using gears on robots? Well, gears can change the speed, the torque, or the direction of a power source. So with gears, it's always good to see the structures and to display and to discover the structures. So here's a whole range of structures, and that's determined by the function that's needed. To transmit movement along a line, we usually use a spur gear with 1 or 2 or 3 idles in between the gears. Then we can also transfer motion from rotation to linear, and that's usually the rack and pinion structure. In this case, we've got the pinion, which is the one that's attached to the motor, and then the rack that moves linearly. And then to transfer movement at a 90-degree angle, we can use a bevel gear, where the gears are at usually meshed at 90 degrees. So there are different types of gears. The spur gear and the crown gear kind of look similar, but the crown gears teeth are facing up. The bevel gear can either have a single or a double bevel gear. The worm gear is then the linear movement, and then you get a clutch which stops, and then you get a knob gear, which is a bit more robust gear. So to build a spur gear train, you obviously have a whole range of spur gears. The driver gear is usually the one that's attached to the movement power or the motor, and the adjacent gears then move in opposite direction. So if you have 3 gears as pictured, and the one gear is turning clockwise, the second one will go anti-clockwise, so it means the third one will then again go clockwise. So this is an example of a rack and pinion gear. So the rack moves to the left and the right, and then the pinion is the one that when exploring the different options with a spur gear, obviously attaching the axle and the motors, you can always change the power settings to 50% or 100%. That'll give you a way of discovering which is the more efficient way of doing it. So again, to get the code to move a bevel gear, you can have the axle attached to the large motors, and then your structure is attached to a motor. And then again, if you want to run the program, you would say, let's change the power settings to 50 or 100%, and then you need to be able to describe what the impact of that change is. Now we come to unit 3B, and this is powered attachments. So passive attachments, which we discovered in unit number 1, are the attachments that don't need any specific programming and are not attached to any motor, whereas powered attachments are attached to a motor, and then obviously there are a large diverse range of powered attachments. And in a powered attachment, even if you do have the building instructions, I highly recommend that you use that then as a frame of reference, and you encourage your learners then to explore and find out other ways of modifying these powered attachments. However, powered attachments are usually attachments that have attached to a motor, and you can use gears in that, and then you require some form of programming. So what are the powered attachments, or where are the powered attachments attached to the robot? Well, usually in the front, in the center, or at the back, exactly where they are needed. And how are the powered attachments attached to the robot? The attachment must be connected as a structure and then wired for function. So these are the attachments that come with the Riley rover. They can grab, they can lift, and they can push. And they have to be multi-purpose. All right. So attach the grabs to collect and to release, and the lifts. So 2 examples that are used for the Riley rover in the building instructions is the gripper and the cargo loader. So do you notice that the cargo loader will then go from up and down, so you can drop something. But very similarly, if you just modify the structure, you can actually go the other way around. You can have something where you take the arm down to pull something, right? And then in both cases, the motor is connected to port number A because you need to be connected to a motor. Okay, the example here, this gripper has spur gears that are meshed to move the two arms toward and away from it. And if the gripper arms are modified, well, you could maybe hold a bigger object, right? The cargo loader here has got knob gears that are meshed to move the arm then up and down. But similarly, that arm can be made bigger and or smaller. If the cargo loader delivery is turned the other way, as I said, then that will give you the power to pull something towards you. So an example of an arm that goes up and down, this is with the two knob gears that are attached to a media motor. For the cargo loader, the arms moved using two knob gears. There's one. And the arm can move then down to the ground and up towards the robot. Remember, the robot arm can only move as far as the structure of the robot allows. If we were to build the gripper with a spur and the worm gears, as you can see from this diagram, the arm is controlled by an axle in the media motor, and it's meshed with two spur gears. And the axle is then attached to the arms. So if you have to program these powered attachments, the powered attachment needs to be built and then attached to the robot. And then only can you start figuring out the programming that is required for these powered attachments. If you start with an arm, it is obviously first best to understand where your starting position is, either up or down. If it's going to be up, then you're holding something maybe, and then you need to drop something. That needs to be defined. And then you need to define whether going up or down is positive or negative. So in this case, it's for 20 seconds, no, for 1 second with 20% power, and you'll test it. So this will be the positive power is the going up for this specific robot. All right. So then to go down, then it'll require negative power. If I can just add here that it is with time. So the functioning of an arm is always on time because time passes. You need to make sure that your robot can perform all the programming that is required. All right, shall we continue the up-down? So if up is positive and down is negative, then you need to include in the task the robot must be able to move, to drop something, and then move the arm up. You cannot leave the arm down because then it drags on the surface, and that is just delaying or friction for the movement of your robot. Okay, so in this case, you've got your arm, and you move your arm up, then you wait for a second, then you go forward, and then you go down, so you've dropped something, and then you reverse. Except in this case, your arm is still down. You would need to modify this code. So again, here now we have to move the gripper to actually grip something or an object or something. Again, you need to have a starting position, and it needs to be well defined. Then you test whether it's positive, is opening or closing, and then the control must be time. So for this unit, there are some challenges. You have a range of challenges from which you can select one. And you need to apply the learning of a specific situation. So you have to combine the building and the programming. So you need to understand the robot must move forward, he must move some items, and then he must return to the starting position. But try with additional items and then evaluate the efficiency of your robot. So as you can see, there are a large range of additional video resources that are available on Gears. The trick is, however, for all of these connections and links, you will need to actually build a model or build something that you can show your learners to explain the idea. What is a gear train? What is a dog gear? What is a spur gear? What is a bevel gear? There is so much explanation, and there are really amazing videos available. So if there's one recommended reference that I have as a book, the one is A Winning Design. For EV3, I have also got the NXT version of it. It is a good book to read to understand and get an overview of this whole thing called robotics. And so we've come now to the end of Unit 3 of M2. There's a quiz, and there are definitely some building and programming activities with gears, but there's also some building and programming activities with powered attachments. And I really encourage you to try as many as possible, to explore, to make the robot move, to see whether the attachment moves. And then there's a challenge. So when you've finished your quizzes, your 2 quizzes, choose a challenge and take on the challenge. And once again, if you have any troubles, you are more than welcome to contact us. I thank you.